Okay.
I'm going to introduce you and then hand it over.
Sure.
40 minutes.
Okay.
And then Q&A.
Okay.
Good afternoon, and thank you for joining us today. I am Amani Jamal. I'm the Dean of the School of Public and International Affairs, and I would like to offer a special thank you to Gil Oman and Martha Darling for their generous gift that has made today's event possible. I'm honored and excited to stand before you and introduce today's guest, Dr. Moriba Jah. Dr. Jah is an associate professor at the University of Texas at Austin, where he holds the Mrs. Hurley Dashiell Henderson Centennial Fellowship in Engineering. At the University of Texas at Austin, he has worked with a team to develop Astrograph, an award-winning near real-time map of where objects are predicted to be located in space. Dr. Jah is the chief scientist of Privateer, a data and intelligence platform empowering the future of space sustainability, which he co-founded with Apple co-founder Steve Wozniak. As a renowned space environmentalist and astrodynamicist, Moriba brings a wealth of knowledge and expertise in space object detection, tracking, identification, and characterization, as well as spacecraft navigation to the Privateer team, where he is developing the first highly accurate space traffic map that aggregates multi-source data on Earth orbiting space objects as a means to power the new space economy and make space exploration safe and sustainable. Moriba's resume includes his work as a spacecraft navigator at the NASA Jet Propulsion Laboratory, where he was a navigator for the Mars Global Surveyor, Mars Odyssey, Mars Express, Mars Exploration Rover, and the Mars Reconnaissance Orbiter. And not to bury the lead, but he is a recipient of the 2022 MacArthur Foundation Genius Grant. So join me, everyone.
Thank you so much.
Oh, no, I'm not done yet.
Oh, wow.
Sorry.
Oh, wow.
I got
Okay.
2 more pages.
Okay. No.
Jah's work also extends to policy guidance and public education about how to improve collaboration across spacefaring nations and entities. In op-eds, podcasts, and government testimonies, he is a persuasive advocate for space environmentalism, a framework for treating Earth's orbit as a finite natural resource. Like other natural resources, it should be governed by norms of behavior, transparent information sharing, and broad regulations in the service of sustainability and equitable international access. Jah proposes enacting policies to create a circular space economy. Such regulations could prevent pollution in the form of single-use satellites and incentivize companies to reuse satellites rather than abandon them. Through his transdisciplinary approach and vision of space as an invaluable global resource, Jah facilitates greater understanding of the environmental challenges arising from human use of Earth's orbital spheres. I leave you with a quote from our esteemed guest. Humanity finds itself plagued by unacknowledged existential crises because it has forgotten the interconnectedness amongst all things and its intergenerational contract of stewardship. My Dharma is to remind humanity of this discrepancy through evidence and to recruit empathy and time to rescue spaceship Earth from its current course. I seek to show humanity a path for itself through a lens of space environmentalism and sustainability. Please join me in welcoming Dr. Moriba Jah. Now,
Can you give me a hug? Thank you.
Thank you so much. Thank you for coming.
Yeah, thank you so much. Wow. Yes. It's like, have I been doing all those things? Maybe. No, thank you so much. It's an honor for me to be here. And the first thing I'm going to say is that we don't have enough time together. I already feel that way. My day has been back-to-back meetings, and I have to say that each and every meeting that I've had with folks here has filled me with a lot of energy, and your questions have been so insightful that they've made me think. And so to me, that's a great sign when students ask me questions that make me think about what it is that I'm doing and make me pause before I answer. That's really cool. I really appreciate that. And this is all to say that I want to acknowledge that I am in a special place with all of you. And so it's my honor to be with you here today. So let's try this technology thing, since all this stuff works as planned always. Let's see. I know that there's a little bit of a lag here. Here we go, because I know that there are people online. So I guess the first thing that I want to do is show you this thing called Wayfinder, if this works. Okay, so here we go. So it turns out that, in 1957, humanity launched its first object in a space, Sputnik, and currently this is a nowcast of every single dot is a human-related object being tracked by somebody in Earth orbit. If I add in the rocket bodies and fragments to this, it looks something like that. The dots are not to scale, it's just location, but it kind of gives you an idea of things. And basically the cyan dots, which you can kind of barely make out. So cyan dots are things that work, meaning they're producing some sort of service and capability that we care about, supposedly, like position, navigation, and timing, these sorts of things, services and capabilities, right? Communications, internet, that sort of thing. But all the other dots that are not cyan colored are basically things that are junk, okay? So all the other colors are different pieces of junk, whether they're rocket bodies, fragments from things that broke up over time, and that sort of stuff. So this gives you an idea. Here's a Starlink satellite as an example. In here in Privateer, this company that I co-founded with Alex and Steve, you can kind of get an idea of where these objects are located. You can click on anything and get some more information on these things. You can download some of the trajectories and that sort of stuff. But in any case, this kind of gives you an idea of some of these orbits. And, I'm going to be talking about this environmentalism here pretty soon. But basically what we've done to land, air, and oceans in terms of pollution, we've done to space. We've said space is big. Mother Nature will take care of it. It's all going to work out. It's all going to be okay. And those have been words repeated over centuries by humans, and it's always been to the detriment of the space environment. Something else I'm going to show here, this thing. This is called the conjunction streaming service. Basically what we're doing is we're saying this, okay? Over the next 20 minutes continuously, out of about 20,000 objects, which pair of objects do we predict will come within 6 miles from each other? And if so, show me. This is what traffic in low Earth orbit looks like right now. All of these things are near misses, where near misses are within 6 miles. Of course, the near misses aren't collisions, but it's just giving you an idea qualitatively of how many things are coming within 6 miles of each other over the next 20 minutes. It's busy. I've seen the numbers go up. The relative speeds in the crossings are 15 times the speed of a bullet, and the smallest thing that we're tracking is about a cell phone, which is many times larger than a bullet. So if a bullet does some damage at the speed of a bullet, something several times the size of a bullet traveling 15 times its speed hits anything, and it's a bad day, okay? It's a bad day for anything. The altitudes at which most of this stuff resides is sun-synchronous orbit, but there is a cluster that's growing around 500 or so kilometers, which is where Mr. Elon Musk is placing the Starlink satellites. So you get the picture. Things it's busy. It's busy. I'm going to stop that share and just go with the slides. And I know that we have 30 to 40 minutes, so I'm going to apologize to you right now because this is going to be, as they call, death by PowerPoint. And I'm going to try to go through this stuff fairly rapidly, so it's going to be drinking from a fire hose. And when I was at MIT giving this similar talk, basically they said, we at MIT, we're smart, we're used to drinking through fire hoses. I'm not. So if you're comfortable with that, then I'm happy. All right, so here we go. So we have this environment near Earth space, and it's very dynamic. The sun's doing stuff. We have curvature of space-time, charged particle environments. You folks here actually know a lot about that. You have astrophysicists. We went to the space physics lab where you have real instruments measuring some of these things. So I'm not here to tell you what you already know, okay? What I will say is that in that environment, we have human-made objects, and we don't fully understand the effects and impacts of that environment on how these objects behave, whether they're operational or defunct. And coupling on top of that, there's been no domain of human involvement that has been without malicious behavior. So to think that, oh, when people explored land, air, and ocean, it's all about, everybody's benign with each other. Clearly, no, you've known there's piracy, banditry, all these things. Space is no different. Just because it's outer space doesn't mean that everybody's into like having pillow fights and tickling each other kind of thing, right? I mean, there's like not so good things that happen, even though, that sounds nice. But yeah, anyway, I digress. So their threats are real. Now, the other thing to point out is that we don't launch things into random places in space. Depending on what we want these objects to do, we put these things in very specific orbital highways. And what you're seeing here is, this is just a snapshot of me taking about 4,000 of these human-made objects, anthropogenic space objects. I use the word anthropogenic because I'm trying to connect what I'm doing to environmentalism and sustainability on land, air, and ocean. I don't like making up my own terms. I like borrowing terms that are standards that other people have used. So I'm a borrower. I love borrowing. And so these 4,000 objects, I've taken their position and velocity, just computed the cross product of position and velocity to obtain specific orbital angular momentum. And all these objects are now shown in this specific orbital angular momentum space, where the color is the relationship of the orbital plane with respect to the equator. So this is saying that something that has a 0 degrees inclination of its orbital plane is orbiting pretty much in the Earth's equatorial plane, and things that are like going at 90 degrees would be like polar orbits and that sort of stuff. I've done nothing else to this except to say that this does not exhibit randomness, okay? You can see rings. The stuff that's there kind of lower on the bottom, those are things in low Earth orbit. The stuff at the top, the halo at the top is geosynchronous or geostationary kind of orbits. And then you have geotransfer orbits there in the middle. I don't know if this laser thing, yeah. So this is geosynchronous. This stuff is like geotransfer orbits. These are all LEOs. These are things that are, I guess, going into retrograde orbits. But you can see these kind of highways in this. I've done nothing to the data except just see what it looks like. And you can already see that there's structure, okay? Patterns emerge. Structure and patterns are good because it means that there's something that we can infer that could help us with predictions. If everything's really random, there's nothing you can do about that. Like, there's nothing to learn out of just inherent randomness. Okay. So we're interested in the entire population of these human-made objects. So to know something, you have to measure it. To understand something, you have to predict it. Prediction is the key. We can't measure the entire population, so we can't conduct a proper census statistically, but we can measure samples of this population and hope to draw conclusions about the entire population from the samples using inferential statistics. But it means that all the conclusions that we are drawing are mired in uncertainty. That is inescapable. And so to kind of, I said I was a borrower of words. So in paraphrasing Rudolf Emil Kalman, the co-inventor of the Kalman filter, uncertain data cannot provide exact models unless we apply prejudice to remove the inherent uncertainty. Prejudice. That is something I'm going to keep on repeating in this. We as humans don't like uncertainty. That feels uncomfortable. It brings us discomfort. And usually if we're sitting in that uncertainty, we will apply prejudice to make that go away. You're going to see where that could lead to erroneous kind of conclusions. So that said, the inferred space object population in 2010 was as pictured here. Basically, this was me working at the Air Force Research Lab on Maui. We had about 20,000 objects that we were tracking. About 1,200 of those were operational. That means everything else was junk. So it's like 96% of all the stuff that we were tracking at the time was garbage, okay? And I'm like, in what other field is this acceptable? That 96% of the stuff we put out there is trash. But space, it was, and that was okay for space. Now, inferred because basically we're trying to say, well, if things down to a speck of paint, how many do we believe there are? And right now we hypothesize there's probably at least 1 million human-made objects if we go down to a speck of paint. But the smallest thing that we're tracking, okay, in the sampling of the population is about the size of a cell phone. Here we are in 2023, 48,000 objects from the 20,000, okay? So we've definitely doubled in the amount of stuff that we're tracking, and we've gone many times over in the things that are active satellites. And I can tell you that about half of the things that are working all belong to Elon Musk. I'm not saying that's a bad thing. That's just a fact. Half of all working satellites that humanity has are SpaceX satellites. And that number is increasing. By how much? Let me tell you. On a busy year, we used to launch 12 things a year, about once a month. That was a busy year for launches. Right now, the rate of launches is averaging to over 12 satellites, not per year, but per week. We're putting more than 12 satellites in orbit weekly, on average, while you were asleep, kind of thing, okay? So, borrowing words and turning phrases around, out of one common environment, many competing needs. There are hazards in orbit. One of the problems is that out of the working satellites, we don't have, if this was the day of like Star Trek and that sort of stuff, right? We could have force fields around the satellites and then nothing could break the shields or whatever, right? Give me more power, Captain, the shields, right? We don't have that. So basically anything that's this piece of junk, especially the stuff that we can't track, could collide against one of these working satellites and then it's game over. Degradation of the capability is the least of the concerns, is completely obliterating the thing and then it being gone. And we don't have these satellites sitting on shelves ready to launch except for SpaceX. But other folks don't. And basically this stuff has a high cost to it. From the security perspective, it's not just governments, but it's also commercial companies maybe not doing great things with each other. And there's this escalatory behavior that you can see in the news, the saber rattling. The US says Russia's doing this, China's doing blank, China says the US doing this. Nobody's actually giving evidence of that to let you draw your own conclusions, but that's what's going on. Geopolitical tensions are increasing. I can say right now that on the current path, there's a guaranteed armed conflict in space that will happen. On our current path, it's not if, it's when. We will enter into armed conflict and space will be one of the prime things that is targeted. I actually believe that that has already happened, and I can maybe allude to that later, okay? On the sustainability issue, and when I say sustainability, I really mean humanity's ability to utilize a finite resource in perpetuity. And that is being sacrificed because everybody's like launching as much as possible in an uncoordinated fashion. So we actually need to understand the environmental impacts of our behavior, and I'll get into that here in a little bit, and have some sustainability metrics that go along with that. So there's this thing called space domain awareness, really awareness of what's going on, not just in space, but the things that influence what happens in space. And the things that it should provide, the three measuring things, the metrics of space domain awareness should be transparency, what's up there, who does it belong to, what can it do, predictability, what does the population look like now over the next few minutes, hours, that sort of thing, and can we predict how any two operators will make decisions given a common source of information. By that I mean, if there is a collision warning that is provided to Acme Incorporated and Das Vidania LLC, what will they do? Will they actually move out of the way? Will they just play chicken and not move? I can tell you right now that I have interviewed space operators that I will not mention in this room. I've interviewed space operators that have specifically told me, my satellite is pretty cheap, and it's cheaper than the other satellite, and so I got nothing to lose, and these other people will probably move before I do. That's not a good thing to be doing in orbital space, okay? And then accountability. How do we develop a body of evidence that can be used to help people make safe decisions and hold them accountable for their behaviors on orbit? Okay, so those are the three things that I feel need to be metrics in space domain awareness. What's part of the problem? Uncertainty, ignorance. The thing is, the evidence that we have, when a satellite stops working, many different things explain the evidence. One of them is Mother Nature did something. There's a charged particle kind of thing that hit my sensor stopped working. That's one explanation. What's another explanation? Oh, Jimmy has a satellite and schwacked my stuff with that, 1.21 gigawatt whatever, and now my thing's not working anymore. So many different hypotheses that can be very different from each other explain the same evidence. Ambiguity. We don't have one-to-one causal relationships to explain anomalies on orbit. That is a problem, and this is where the prejudice comes in, because if for whatever reason I have some US satellite that is of high interest and it loses some capability, and then hours before then, within 100 kilometers, there was a satellite from a geopolitically distant country, my first inclination is to say they did something to me. Not that I have information that says that, but I'm going to use my prejudice because I don't like the uncertainty. And I don't know if it was Mother Nature that did the hiccup, but I'm just going to assume that somebody did something evil to me. Threats exist, for sure, absolutely. I know that for a fact. I've seen the data on threats. I was with the DoD for 10 years. They exist. But not everything that doesn't have an immediate explanation is a threat. And when the null hypothesis is everything is trying to hurt me, that is a bad proposition. When the null hypothesis is that everything is a threat, it leads to conflict. Guaranteed. So, what are the criteria for failing to reject the null? No data, not enough data, and overwhelming evidence that the null is true. Hold on, no data? So I don't have any evidence and I'm going to believe everything's a threat? Not so good, okay? We do have an arms race in space. I have asked different countries, do you want peace in space? And people say we want harmony, which was an interesting response. There's a lot of ambiguity. We don't have persistent, ubiquitous observations of everything that's going on, okay? So what are the ingredients of a threat? So here, if you don't recognize who that is, that's me at 19 years old. I was a security policeman in the US Air Force guarding Minuteman II and Minuteman III systems at Malmstrom Air Force Base in Montana. In those eyes, you see determination and all-knowing. I'm like, I've conquered life. At 19, I know everything. What could go wrong? Yeah, that was far from the truth. But I did learn one thing. Threat requires the concurrent existence of three things: the opportunity to cause harm, the capability to cause harm, the intent to cause harm. Opportunity comes from geometric relationships, these sorts of things, the physics. You can kind of see opportunities of threats, harm. Capability, that one's harder. That's not just tracking stuff, that's knowing payloads. Does this thing have a grappling arm? Does it have this laser on board? Does it have this, that, or the other, right? That's harder to get to. Intent. There's no intentometer out there, okay? If you know of one, let's talk. We're gonna make a lot of money. So this is where prejudice is applied, because people feel uncomfortable in the presence of ignorance. People don't like that, okay? They don't like that. So some practices that we should develop for space security, right, is can we develop some database of multi-source information? Can we monitor, verify, and assess behaviors and cross-reference that stuff? Like for nuclear weapons, I remember working at Malmstrom Air Force Base. There was a truck that was there was a truck that always went to a given missile silo to do maintenance. It was down. Another truck replaced that because it was down. And within 2 hours, we had a call from the Soviet Union at the time. I'm dating myself. From the Soviet Union at the time to the United States, probably DC, to Strategic Air Command headquarters in Offutt, Nebraska, to Malmstrom Air Force Base, asking why serial truck, serial number, blah, 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 went to this site instead of the one that usually goes to that within 2 hours. Everybody's looking at everything, okay? I've seen the satellite pictures back from the late 80s, and I can tell you, and I don't believe that this was classified this time, but I could make out somebody who was smoking a cigarette on the hood of a truck from satellite imagery back in the 80s, okay? I don't even want to know how good that stuff is these days. So monitoring, verification, assessment, coordination, and planning. We don't do that for space. We're just launching as much as we can whenever we want because space is big. It's all going to work out. Capacity building. I'm going to get to this. These are words from the United Nations, right? Trying to develop common knowledge. I'm going to get to that very soon. And people say, oh, we have to enforce stuff. Really? How do you enforce something that you don't manage? How can you manage something that you don't know? And how can you know something that you don't measure? Measurements are a key. So I'm going to skip over this. Traditional ecological knowledge is something that I have found that propelled me towards becoming a space environmentalist. Basically, by living on Maui, looking at the pollution in the ocean, looking at landfills on the small island, all these single-use, plastics filling up the land, going to the top of the mountain, looking at the telescope, seeing the 20,000 pieces of junk and only 1,200 worked at the time. I'm like, I detect a pattern. That's not so good. Okay? Land, air, ocean, and space are linked. Okay? It's a complex system, the system of systems. We're behaving in the same sort of way. I looked at native Hawaiians displaced through colonization. I took a couple trips to Alaska, to Denali, so that my son Denali could see where his name came from, and saw very similar things that I saw on Hawaii, and the detriment to Alaska of abandoning this intergenerational contract of stewardship for ownership. Okay? Ownership says you have rights, claim rights, you have the rights to this, get off my property, blah, blah, blah. Stewardship says you have a responsibility. Stewardship says you have a responsibility. And there are pockets of indigenous folks that believe that all things are interconnected, and they accept that every day they're in an existential crisis, and the only way through it is to have a successful conversation with the environment. Okay? I've spoken to a Wayfinder, and that's why we called it Wayfinder and Privateer. There's a Wayfinder from Samoa, Tafamuina. She basically said, here's the deal. So when we take one of these outrigger canoes to cross the Pacific Ocean, we have to believe in our leader, the leader has to believe in us, we have to think about the structural integrity of the canoe at all times. What's the temperature of the water? What are the swells? What's the pattern of the current flows? What type of clouds are out? What do the birds look like? It's basically real-time, multi-source, heterogeneous data fusion and having a successful conversation with the environment, because or else you don't make it. Because the most desolate part of the globe is the Pacific Ocean, and these people have made it successfully without sextants or any of that stuff. Because they're wayfinders and successful because they are in balance and in harmony with the environment. So traditional ecological knowledge or tech, and I love to call it ancient tech, we forgot about the ancient tech. So we're all about high tech and deep tech at the expense of the ancient tech. The ancient tech is the really important stuff. It's this. It's these principles and tenets about how to be in balance with the rest of the earth. Okay? And if we don't come back to ancient tech, we're done. Because we can't, the way we're living is not sustainable. I'm not going to sit here and talk to you about climate change and all this other stuff, even though I know hopefully most people see that that's. But I'm not going to be a Greta here. Greta's cool. I love Greta. I love the fact that she can like tell older men to like be quiet and get in their seats, and it's beautiful. We need Greta. I'm going to be a bit different. And I'm just going to say, we're living in a way that is not sustainable. Humanity is living in a way that is not sustainable. And we need to look at pockets of people that have achieved sustainability. What have they done? And it's in tech. How can we predict what's going on in space? How can we expect the practice of operations to be common if the knowledge isn't? This is the capacity building stuff. For whatever reason, the people that have been operating in space for so many years think that's the secret sauce. I'm from this country and I've been operating for decades, and I can tell you where my satellite is to the angstrom, and I'm really awesome, and I'm not going to share that knowledge with anybody. Because that gives me dominance and superiority. Let me tell you something. Nobody can prevent somebody from launching in space, and in fact, nobody has been able to. And one of the things that I think that whole mentality is like the dumbest thing possible, because here's the deal. How many people in this room believe that they're excellent drivers? You can raise your hand. Anybody? Okay. No, don't be shy about it. Cool. Excellent driver, right? How many people feel that you're more awesome than anybody else out there because you can drive better? That doesn't make me feel comfortable. If I hoard the driving skills, that means that I have to be more of a defensive driver, because there are other people that they're not as awesome as me on the road, right? Why would that be beneficial to me? So the thing is, the knowledge of space operations, the awesomeness through trial and error that we've discovered, the effective practices of space operations, that should become common knowledge. Don't give a Lamborghini to anybody who wants to launch in space. I'm not saying that. But give them driver's ed. So we haven't even done that. I can tell you, having chaired NATO activities, given lectures throughout the NATO alliance, across the NATO alliance, there's a huge disparity in understanding what's going on in space, even amongst NATO countries. That's not even consistent. We need to come up with sustainability metrics for the domain. Carbon footprint, analogous kind of thing. I call it a space traffic footprint. Think of it as the burden that any given object poses on the safety and sustainability of other things. When I get into my car and I put it in reverse, I start it, I'm a burden to every other pedestrian and driver at the time. And even though other pedestrian and drivers can predict my every move, if they could do that, the fact that they have to take into account my existence for their own safety constitutes a burden. Okay? So everything is a burden to stuff in space. We need to come up with something like a space traffic footprint to start quantifying that burden. Because then if you can do that, then you can say, hey, I want to pay you to remove this object from space. Why? Because it has a large space traffic footprint. It's a large burden. You can start quantifying the impact to the environment with that sort of stuff. You can put a dollar sign on it. $10,000 for a footprint this big or whatever. Give credits or whatnot. You can't do that in the absence of sustainability metrics. Orbital carrying capacity. I showed you the highways, okay? Stuff dies on orbit and keeps on going at high speeds for very long periods of time. The rate at which things are removed from space by natural occurrences is far less than the rate at which we're putting stuff in. That's not a great equation. That's not balanced. What does it look like when the capacity is saturated, when we can no longer prevent undesirable things from happening? Okay? Then it becomes unusable. If we're trying to prevent bumping into each other, trying to prevent spending, I talked to somebody from NASA day before yesterday, and he said, we can no longer effectively get the science that we want out of the satellite because we're always maneuvering out of the way of a possible collision. That's a detrimental impact, okay? Circular economy. Again, I love borrowed words, right? This is not necessarily in the context of space, but here's a cool thing. What if governments incentivize industry to manufacture satellites and rockets, put that stuff in orbit, make these things recyclable so that it wouldn't have to come back to Earth, but basically at the end of life, it wouldn't just sit there dead. You could actually do something with it. You could repurpose it. You could put it in other orbits, right? You could redistribute that sort of stuff. And for the things that couldn't be recyclable, you could actually come up with a mechanism that was responsible for the disposal of this stuff, where you force it to re-enter, you make it out of materials that when the thing burns up, it's not going to pollute the atmosphere as it's burning up, that sort of stuff. This is possible. Governments can do this. There's money to be made by implementing a circular economy in space. Industry could get behind this sort of thing, right? So capacity, back to the orbit, is it just cleaning stuff up? No, technology also helps with that, like air traffic, right? I mean, capacity in the air wasn't because we removed planes. We actually put a lot more of them up there, but we have technology. We do a better job of supposedly sharing information with each other and coordinating kind of things and filing the flight plans, and GPS receivers give us like several feet worth of uncertainty and errors and stuff like that. So science and technology has a role in providing more capacity to orbits. We could look at maritime and salvage laws, right? We could apply salvage laws to space and say, hey, contractual salvage, you can get hired, remove this sort of thing. You can be like the tow truck person, Astroscale or whatever, get paid for that. Pure salvage, if there's debris that doesn't have like an owner or a launching state identified with it, then maybe people could get compensated by some fund at the UN for removing junk just because that's a good thing to do. But we also have to watch with flags of convenience. I'm sure that's already happened, where people are going through other countries where the regulations are not as stringent to put stuff on orbit. But we don't know because we haven't measured that stuff. But my intuition says this has already been happening. When it comes to the uncertainty piece, this is critical. So there's this whole thing, like Donald Rumsfeld said some years ago when he was Secretary of Defense, oh, well, we have known knowns, and those are the things that we know, and blah, 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 and this and that. Kind of funny hearing him say the thing, but there is some rhyme and reason to that. So the first term are things that we are aware of, and the second term are things that we have measured. And again, to know something, you have to measure it. So a known known is something that we are aware of having measured, best place for decision making. A known unknown is something that we are aware of that we have not measured. You better put some uncertainty on top of that to protect yourself when it comes to decision making. The unknown unknowns are the enigmas, things that we are unaware of and have not measured. So the purpose of big data and aggregating massive quantities of disparate heterogeneous data is because we want to see, can we, through big data, get into the unknown knowns, things that we are unaware of having measured, pose interesting questions to the big data set, see what we can discover from that, and move that into things that then we are aware of having measured. In the Department of Defense, we have this thing called the OODA Loop, Observe, Orient, Decide, and Act. This guy, John Boyd, in 1984, kind of put this thing together. All DoD people talk OODA Loop kind of parlance, and I can tell you that we have a lot of OODA loops, Observe, Decide, and Act. The Orient part is not done well, okay? The Orient part is not done well. What do I mean by that? I hear, oh, we need data lakes and repositories, lots of that, glorified drop boxes full of data and stuff like that. Oh, you want to find something? Good luck. Find it there, scattered across the floor, okay? This is absence of data engineering. For all the people in the room that love the data science, AI, ML, blah, 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 whatever the latest jargon is, right? You're going to get garbage if this is what you're dealing with. And if you don't pay attention to the Orient part of the OODA Loop and do something like that, you're done. This is what's necessary. This is what's necessary. This is the very unappealing, unsexy part of dealing with data, is curating this stuff, applying dimensions of data quality, timeliness, accuracy, completeness, uniqueness. What's the source? What measured it? This is what's required. One of the things that I did at UT with Astrograph is something like that, to say the bottom floor is the scattered stuff on the ground. I basically got people to say, let's curate this stuff. Let's come up with a lingua franca internally with interpreters that can go to all those books scattered on the ground and organize these in something that is semantically consistent with a data dictionary, a data thesaurus, and that sort of stuff, so that people that have questions can just not deal with the stuff scattered on the ground. They can go to the library and ask a variety of questions. Knowledge graphs allow that sort of thing. The things that affect our perception of how things move and behave in space isn't just the real physics, but our models of them, which are flawed and imperfect, the sources of information that we have, the models that we have of those sources, and our method of inference. So instead of just the one thing, it's 5 different things. And we have to pay attention to each of these things. Astrodynamics 101, things move in space because of curvature of space-time. Isaac Newton would basically say that there is a kinetic explanation to things. Newton, that's what I use in my classes, and I've coded that sort of stuff, and clearly stuff works. But then there's a kinematic explanation that Einstein provided, which is quite formidable. And gravity is not a real force; it's just curvature of space-time. And real forces are all not non-gravitational, in my opinion. We can have a debate over that over drinks later on or something like that. But in any case, so you have Earth, curvature of space-time due to the presence of Earth. The moon, the sun, you have photons from the sun that are interacting with the different surfaces. These things are heating up the satellite surfaces are reflecting some of that, some of it is absorbed and re-emitted. You have antenna thrust, you have the fact that the Earth is actually reflecting sunlight as well, and heat, and the fact that the antenna, when it communicates, Newton's kind of third law sort of thing, action equal opposite reaction type of stuff. And there's tidal effects. Detecting versus tracking. So people say, what's the difference? Isn't it the same thing? No. Sensors detect, sensors don't track. There is no tracking sensor. Okay? Sensors detect, they sense. The tracking is the interpretation of what's sensed. That's algorithms, that's physics, that's other stuff. So this is a single night's worth of detections from the Space Surveillance Telescope. Okay? All the dots are detections. The black dots are things that are tracked, things that we believe we know the identity of, and everything else is unknown. Most of the stuff up there is dead and it's not transmitting its identity. So the challenge is, how do you collect different buckets of sensors, okay? And there's no identity in any of these buckets of data from different operators and this, that, or the other. Aggregate that to come up with the first and last name of these objects in space. That's a challenge. We'd love to start on the left-hand side of things that we measure. What combination of these measurables lead us to get physical understanding of these objects? What physical traits and combinations thereof lead us to functional properties, operational, and a taxonomy? There is no taxonomy for human-made objects in space. There's a taxonomy for living organisms. There's a taxonomy for natural objects in space, stars, asteroids, that sort of stuff, right? There's no taxonomy for anthropogenic space objects. That is a problem for a variety of reasons, not the least of which is regulatory. When we regulate things on the road, traffic on the road, semi-trucks are regulated differently than Vespa scooters. On the seas, oil tankers are regulated differently than kayaks and canoes. In space, rocket body equals CubeSat. Are you kidding me? That makes no sense. So we don't have a classification scheme for stuff in space that's human-made. Astronomers, astrophysicists in the room. Light pollution. Told you I'd get there, man. That's how that young dude that you saw with the beret sitting by the peacekeeper vehicle as a security guard. I was in a dark place, Montana. I grew up in Caracas, Venezuela, lots of city lights, lots of light pollution. I could see the moon on a good night. When I went to Montana, I was like, holy cow. I actually never knew that I was in such great company from the universe. I'm like, all these stars, all this space isn't empty. It's packed with stuff. That's so cool. Oh, what's that light going across the sky that disappeared all of a sudden? Is that a UFO? Hold on. No, that's a human-made object that was going across the sky that disappeared because it got eclipsed by Earth's shadow. I want to know more about that. So I decided to study astrodynamics. Now, these human-made objects are reflecting sunlight. Here we have like light curves and that sort of stuff. I won't get too deep into that. There's this object, this dead satellite, Topex. It's in a high, low Earth orbit. We understand it quite well. And here you're just seeing returns. Basically, you're seeing reflected sunlight as a function of time. Here's the thing, it's tumbling, it's spinning. Anything in space that is not controlled is tumbling, okay? So this thing is spinning, it's pretty stable. Here you can see the brightness. You can see that there's structure in this. It's not random. And by the way, philosophically, I don't think anything is random. We can talk about that later. I think everything's deterministic, but we're ignorant. So in any case, I digress. So there's structure in this sort of thing, and from the structure, we can actually see that there are features. By counting photons, we can see features in Topex, and these features are persistent from one night to the next. It's not random, okay? But these things, that's actual data around Topex that we got. All the dots are reflections. But what I want to show here, and let me see if I can, this is what astronomers unfortunately have to deal with every night. All the things that you see, these streaks, are human-made objects reflecting sunlight towards like the telescope in Chile, okay? This is over like one night. This is what we predicted at the time. As you're going through midnight, you see less of these reflections, not because there are less objects, but most of these are going through Earth's shadow, so they're being eclipsed. All this, anything in gray is below the local horizon. So this is a celestial sphere around the telescope. This is a celestial sphere around the globe. This is at the site, looking straight up, northwest, southeast. So astronomers have to see through this crap every night. And we're not going to stop launching satellites, okay? So this is an issue. All right, I don't want to show that again because it makes me cry. Why do we want to aggregate independent sources of information? Well, because we want a more complete picture. Too many people are arguing about how they have the truth, and that's not a thing, okay? Nobody has a truth sensor. The truth about all sensors is that all sensors lie. Every sensor is biased and corrupted with some sort of noise or something, okay? So I showed you Wayfinder. If you wanted to see what the truth from the US Department of Defense was on what space looks like, you'd see something like that. And if you ask the Russians, you see that. One of these things is not like the other, right? That doesn't look the same. We don't share observations with each other. We don't share observations with each other. When we ask 4 people about one satellite, we get 4 different opinions. Some of these are statistically consistent, at other times very inconsistent. Move out of the way, it's going to crash against you. Which one? 1, 2, 3, or 4? People don't behave the same way, even when it's a common law. Case in point, we looked at UN registration. I came up with some system of 5 stars if they register within 120 days. So UN has something that says when you launch your stuff in orbit, register your space object with the UN Office of Outer Space Affairs. Okay, as soon as it's practicable. So that's what the treaty says. If it's within 120 days, I give them 5 stars. Within the first year, 4, so on and so forth. Okay? one law to rule them all. If everybody interpreted and implemented this the same, you would see it would be a uniform distribution. It's not. The numbers at the top, cover your left eye, no, I'm just joking. So the thing is, this is from most satellites to least, but I guess what I want to show you is like, I don't know, Spain has a few satellites up there. It got like 3 stars on average. Let's see, what was 3 stars? Yeah, basically it took them 2 years to hit send to register their stuff with. Why is that? Really? As soon as it's practicable is 2 years? So the thing is, you can't manage the space stuff unless you know things, and you can't know it unless you measure it. The UN has no idea how states party to the treaty are actually interpreting and implementing the laws that they have had people sign. So that's a problem. Anyway, I'm going to leave it there. Basically, ask yourself, whenever a model is built, is it proper to ponder the following question? Is the model really based on the data, or is it an artifact of my own prejudice? Thank you very much.
Field your own questions?
Yeah, I mean, yeah. I'm
like 15, 20, we have about 20 minutes for questions.
Yeah.
Hi, my name is Rudy. I'm an undergrad here at the School of Public and International Affairs. And my question is basically, or rather, if you had the power, let's say, to have a nation or have a private company or, what would you say?
And you might as well
Yeah,
just,
might as well, yeah.
just take the mic, man.
All right, there we go.
Yeah.
Sorry about that.
No,
Basically, if
yeah.
you had the power to either, if you had the power to do something right now, the most immediate action, and let's say that you had any barriers removed, whether it be the geopolitical ones or how we were talking about different countries not communicating with each other and the biases and different perceived truths. If you're able to remove any of those barriers, what is the first step or first action that you would recommend, or if you were one of a country, an international organization, do to start getting on this path of sustainability in space?
So, and this has been the thing that I've been recommending to countries because I advise a couple of them. The first thing that I would do is I would say, find First Nation and indigenous people and ask them what they would do. Yeah. Look, the toughest thing is not technical, it's not political, it's absence of empathy. When I show people this stuff, it's shock and awe. Oh my God, I can't believe, wow, that's a lot of trash. But what am I going to do about it? Or, that's not my problem. That's not my problem is the response one gives when one feels oneself independent of that thing. And what I'm saying is that I believe in the interconnectedness of all things, and if you truly believe yourself to be independent, in my opinion, you haven't looked deep enough, you haven't looked long enough, you haven't looked far enough. And when you extend the yardstick in those dimensions, you will see that you may escape some things in your own life, but the lives of those you love and those engendered by them will not be escaped. So the thing is, everything's interconnected, and the lack of empathy is because people see themselves as independent from these things and they don't get it. And so I would love for people to become empathetic somehow, but that's not something that you can force. Yes, sir.
I might be naive, but how realistic is it to place constraints on companies that wish to launch into space to have a full life cycle plan for their space vehicles?
Yeah, excellent. It's not naive. Governments can enforce that right now, okay? So then the question is, why aren't they? So without getting into names, I can tell you that I've talked to government people that are like, space is finite, there's so much capacity, and I want my own people to get there first. It's a race, man. And people are racing to the detriment of the long-term sustainability of the environment, unfortunately.
Lots of questions. It was a very nice talk.
Thank you.
One of the things that has concerned me is the future of the Outer Space Treaty. But to be a little bit more specific, how much of a positive influence is COPUOS, for example, or the UN in this context? Are they a context for this type of an evolution, or does something have to be done independent of them? I have my own opinions, but I'd like to hear yours.
No, good. So, right, the questions about UN COPUOS and how effective, this Committee on Peaceful Use of Outer Space is. I love that at the UN COPUOS in Vienna, that they came up with these 21 guidelines, 93 countries by consensus signed to these things, but these are non-binding. And the only way for them to be effective is if countries now make these space law in their own country. And so that's the thing that I think the UN in and of itself won't have teeth. All the countries that are parties to the treaties have to take it upon themselves to basically enforce that on their own people that they're licensing. And I don't think that happens in the absence of showing that the emperor has no clothes and making evidence very public about the unintended consequences of the decisions being made.
Sorry, I was curious about what are some of the biases that y'all have to deal with Wayfinder in terms of your own tactics or own tactics and sensors?
So when you say biases, tell me more about that.
Well, you just
Like the sensors, like reporting the wrong thing and that sort of stuff, or what?
well, you just talked about how all sensors are biased.
Yeah, so look, I mean, I have some telescopes. I know that my telescopes have to be calibrated often. The only way for me to really tell if my own systems are reporting the wrong thing is when I can compare with other people's data. Independent sources of observation help you confirm or refute different hypotheses. So I'm always in that process of never just trusting any given source of information, but always trying to check and verify with independent sources. Yeah.
My understanding is that currently the FCC and FAA and their licensing and launch control processes aren't allowed to consider aggregate effects of launches or just more satellites. What do you think it would take to change that?
Well, when you say that they're not allowed to, who's not allowing them to?
I think in the licensing procedure, it says.
But they're the regulatory thing. That's their decision. Like,
It sounds like Congress has to be.
no. Congress has no candle at that funeral. Congress can't tell them what they can or can't. Yeah, that's, no. Sorry. Yeah.
Yes, so you mentioned that certain nations or operators have noted the achievements of their satellites and their lack of willingness to maneuver out of the way of other objects or satellites. What would be the most effective way to incentivize operator cooperation, potentially the most effective way to frame sustainability when this mindset currently exists?
You know, this is where I would love to usher in space insurance companies and basically look at the behavior of people on orbit. And it's like, look, based on your behavior, if you're not changing lanes and you're not stopping at stoplights and stuff like that, sounds like you get to pay more money. Yeah.
Thank you so much. That's really fascinating talk. So I'm trying to draw parallels to other regulatory regimes. I mean, and as a political scientist, the one sort of example that comes to mind for me is nuclear proliferation. But that seems a little bit different. And this is why, is that at the end of the day, nuclear weapons were controlled by governments. So you can bring in the United Nations and everybody would be better off. Here we've seen sort of the privatization of space pollution.
Sure.
And so that the incentives in terms of thinking about first movers in this space, if the United States is going to move first, which it probably should, I'm not saying that it shouldn't, but if it moves first, I can see a credible argument being made that why should we move first and restrict our private sector when the Russians and the Chinese and other countries are not.
Which is what I've seen already. So I can tell you right now, there's no shortage of African countries that have said that to me.
So then
Yeah.
how do we, I don't see, correct me if I'm wrong, I'm not seeing a parallel in recent history that we could use really as a template to think about a new regulatory regime to govern this.
Understood, and I agree with you. I will say that the Outer Space Treaty says that states party to the treaty, Article 6 says states party to the treaty are responsible for providing authorization and continuing supervision of all space activities of non-state actors. And then the Convention of Liability and Damage puts the responsibility on launching states. So governments are responsible for this stuff. But the thing is, it's this catch-22 sort of thing where the governments are like, well, I want to maximize how many of my own people get to utilize space because that benefits my own citizenry and this, that, or the other. And there's enough ambiguity to where who's going to call me on the liability and damage kind of stuff? Who's going to call me on the harmful interference? Who's going to call me on the continuing supervision piece? Yeah.
So on that note, we have the problem here on Earth, right? We have garbage, we pay taxes, it gets collected, the government pays a company to collect it. And wouldn't that work also for space debris, like pay a private company? Like the problem here would be who pays taxes, you know? Like you would have to do like a global tax, you know, so that we don't pay. Or like you would have to go do identification, right? But would that work? Like how do you guys?
Would they pass it on to citizens?
Right, I mean.
Right. So look, I mean, I think that there is a thing to this idea of the circular economy in space. I think that governments could basically implement like extended producer responsibility, where they have to design end of life in this sort of stuff, just like EPR with the whole, okay, if you take the can back, you get the nickel. Like there could be incentives for people to get sustainability designed into the satellite systems themselves, if governments chose to do that. Yeah.
You've mentioned, well, we've all talked about this concept of the circular economy in space. Are there any companies or government agencies that we can point to as an example that's already moving in this direction in a positive way, or doing something that we can draw from as we try to move in this direction? Not really. I mean,
SpaceX has a reusable rocket. So, I mean, we could point to something like that. But aside from that, the answer is no. And companies want to be in the business of removing debris, but there's no marketplace for that because the government hasn't created that marketplace, which I think if you have sustainability metrics like carrying capacity, like a space traffic footprint, then you can monetize that and say, hey, here I am, I'm Amberland, government of Amberland. We have these sustainability metrics. We can quantify which are the worst objects up there that need to be removed. And I'm going to then basically pay you this amount to give this much capacity back or remove this percentage of the space traffic footprint from that orbit. Because most of the stuff consuming the capacity, and you're going to see that the bulk of the space traffic footprint by any calculation is going to be on the shoulders of the US, China, and Russia. Other countries are going to say, hey, I want to launch into this orbit. I'm this African country, but the carrying capacity is saturated with your junk. What are you going to do about it? Which country is going to say, hey, I'm going to start paying people to remove satellites so that some other country can basically use the orbital space? I don't see that happening anytime soon. But yeah, it's.
Can I ask a naive question, follow up on this one? So when we say about removing the junk from space, is it, for example, hypothetically about bringing it back to Earth or dumping it on the moon or just?
So here's the thing.
What do we do with
I don't want to see more landfills, and I've heard lots of, I even heard people say, hey, just send it to the sun. Like that was cheap, right? It's like, oh, just, that takes a lot of energy, right? You got to bleed off like 29 kilometers per second of velocity to get the thing to just drop to the sun. So anyway, I don't want to see more landfills in space. I'd like to see disposal make the thing burn up, but hopefully, at least in the future, things made out of materials that won't contaminate the atmosphere as the thing burns up. There's no good story. I mean, the bottom line is this. if we want to become sustainable in space, and if we want to have a successful conversation with the environment, we actually need to learn how to live with the filth in the bathtub, because space is never going to be like it was prior to 1957, just like the oceans will never be completely rid of plastics and that sort of stuff. So there's a certain amount of filth that will be the norm, and that there's no way around it. For the foreseeable future, we'll always have to live with that. Can we adapt to living with that level of filth without creating more? Yeah.
Do you think it'd be a tipping point though? So there might not be government incentives at the moment, but at some point, companies or nations will want to launch stuff up there
Mm-hmm.
and orbit. The risk will be so great that they'll run into something they'll have no choice but to start.
Right, and then there's then that we enter into non-consensual debris removal, and that is an issue. Because the thing is, you can't just go up to something and remove it if you aren't the sovereign owner of that piece of junk. Right, that's what I'm talking about, man. Complicated stuff.
How do you reconcile national security with like this idealistic idea of data sharing, or even having, you know, a private or commercial company do a robust database with tracking these objects to include proprietary government programs?
Yeah, so this is where I've gotten into, and I'm not going to mention names, but I actually talked to somebody who worked for a three-letter agency a couple years ago, and they came up to me and they said, "So, Moriba, how do you feel if I tell you that the work that you're doing is rendering billions of dollars of government resources into denial and deceit useless?" And I said, "Let me play that back to you. My work is rendering billions of dollars useless. If I can do that, that means that you're not doing a good job of where you're investing your billions of dollars." The thing is, everybody has telescopes in their backyards these days, that sort of stuff. There's no way to protect people from just using their eyes, right? Cell phones and all that other stuff with stuff that happened in the Middle East, right? There was no way to prevent information. Satellites doing Earth observation that aren't military are informing us of what's going on in Ukraine. There's no way to hide that stuff. There's nowhere to hide. So the thing is, if government programs that are of national security are trying to hide what they're doing simply by people not being able to see them, and they have materials that are reflective enough to be seen by others, then that's dumb. I mean, find other ways, right? I don't know, start a company, don't say that you're starting the company, launch a bunch of satellites to do global internet, and basically use that in disguise of your military program. I won't say anybody's doing that right now. All right.
Early on in the talk, you mentioned that it's seen evidence for orbital conflict that's already taking place.
Sure.
Could you expand on that?
Russian ASAT. Russians blew up this ASAT, right, in November. When did the whole invasion of Ukraine happen? Was it that? About 2 months later. Which satellites have been providing internet to Ukraine in a way that would otherwise not have happened? How has the ASAT affected the maneuverability of the Starlink satellites? They've had to maneuver thousands of times more than usual because of the debris from the ASAT. That's a lot of coincidence. It is prejudice. It is prejudice. Accepted. Yep.
What do you think about the potential for the US and China to get together in the intermediate or short term to try to address some of these issues? I think that's a rather key thing.
Yeah, so I can tell you that one of the things that I'm a member of is the Committee on International Security and Arms Control within the National Academy of Sciences, and I can tell you that when I speak to my Chinese counterparts, They're very much interested on the scientific level of trying to bridge the gap in assumptions on modeling and these sorts of things. So I think on the track 2 diplomacy thing, scientist to scientist, there's a lot of will in shoring things up. It's at the government policy, political type stuff where there's disconnects, and I don't know how that gap gets shortened.
Okay, on that note, well, a lot of questions. Please join me in thanking Moriba Job.
All right.
Thank you. It's very illuminating and very engaging and actually very worrisome. So
Thank you. Yes.
Thank you so much.
Yeah. Thank you. Thank you, guys.
Thank you, Moriba.
Yeah. Thank you. Yeah. Absolutely.
So we're gonna get ready and go head home for the dinner.
Okay.